50. That's the number that matters tonight, because sometime in the next few days, on a mountain in Hawaii, the ground is going to crack open and throw a fountain of molten rock hundreds of feet into the air. And when it does, it will be the 50th time it has happened in this single, ongoing eruption. 50 separate episodes of lava fountaining from the same volcano in less than 2 years. And here's the part that should stop you. Scientists already know it's coming. They've told us the window. They've even told us the most likely day. Think about how strange that is. We can't predict most earthquakes at all. We struggle to tell you where a hurricane will be in 5 days. But for this one volcano, in this one moment, the United States Geological Survey has looked at the data and said, out loud, in writing, that the next eruption is most likely to begin on a specific date. As I record this, that window is open right now. The volcano is Kilauea, on the big island of Hawaii, and the eruption it's part of has already done something no eruption at Kilauea has ever done in the entire history of modern monitoring. It has broken a record that stood for almost 40 years. We'll get to exactly what that record was, and why breaking it matters more than it sounds. But by the end of this video, you're going to understand 3 things almost nobody scrolling past the headlines understands. First, how on earth scientists can predict this volcano almost to the day, when they can't do it for nearly any other volcano on the planet. Second, why the real danger of this eruption is not the thing everyone is filming. The lava fountains make the spectacular footage, but the thing that actually sends people to the hospital is invisible, and it can travel 100 miles from the vent. And third, why the terrifying story going viral right now, the one about a collapsing volcano and a wall of water racing toward the American mainland, is not just wrong, but is hiding a real lesson that's far more useful than the fear. This is the Horizon Lab, where we take the headline that's meant to scare you and we show you the real science underneath it, because the truth is almost always stranger than the fear. Let's get into it. If you're new here, this is the channel that reads the actual data, the bulletins from the people whose entire job is to watch these volcanoes, so you don't have to trust a rumor or a thumbnail. So before we go further, do me one favor, subscribe and hit the bell, because when a volcano like this one moves, and right now it's about to, we break down what it really means while it's still happening, not a week later. And tell me in the comments, have you ever actually seen lava in person? Because by the end of this, you might understand why people travel across an ocean for the chance. So let's start with the question that makes this whole story so unusual. How do you predict a volcano? Because that prediction, that confidence, is the thread that unravels everything else. And the answer is going to change how you think about what a volcano even is. Hold that question, because the way Kilauea tells us it's about to erupt is the exact same mechanism that produces the danger no one is talking about. They are 2 sides of the same coin, and we're going to follow that coin all the way to the end. Let's start with what the scientists actually said, because this isn't speculation and it isn't a psychic reading. It's a forecast, built on instruments, published by the Hawaiian Volcano Observatory, the USGS team that has been watching this mountain for over a century. Here's the language they used in their most recent update before this recording. The summit eruption is paused, but summit inflation, vent glow, and degassing all continue, which tells them another episode is likely, and then the specific part. Their forecast models indicate the onset of fountaining episode 50 is likely to begin within a multi-day window, with one particular day flagged as most likely. They put a date on it, a government science agency publicly forecasting the start of a volcanic eruption days in advance. Now, 2 pieces of vocabulary you're going to hear me use because they tell you how worried to be, and the honest answer is, in this case, not very, and I'll explain why. The USGS rates volcanoes on a volcano alert level, and right now Kilauea sits at advisory. That's the second lowest rung. It means the volcano is showing elevated unrest above its normal background, but it's not an emergency. And the aviation color code, which warns aircraft about ash, sits at yellow. Again, elevated, watched, but not red, not orange. The instruments are saying, something is coming, and we are not panicking about it. That calm is itself a story, because this eruption has been going since December of 2024. It hasn't been one continuous river of lava. It's been a stutter, fountain for a few hours or a day, then stop. Pause for anywhere from a day to 3 weeks while the volcano reloads, then fountain again, over and over, episode after episode. And the reason the scientists can forecast the next one is that the volcano has fallen into a rhythm and they've learnt to read it. Here's how they read it, and it's beautifully simple once you see it. Near the summit, they have instruments called tiltmeters. The best way to picture a tiltmeter is to imagine an impossibly sensitive carpenter's level buried in the ground that can detect the faintest change in the slope of the land. When molten rock, magma, rises up and fills the shallow reservoir beneath the summit, the whole ground surface above it swells. It tilts, like a balloon inflating just under the skin of the earth. The tiltmeter feels that swelling and measures it in tiny units called microradians. And here is the pattern that makes the forecast possible. During each eruption, as magma blasts out, the reservoir empties and the ground deflates. It sinks back down. In the last episode, the summit deflated by about 15.5 microradians as it emptied. Then, the moment the eruption stops, the magma starts refilling from below and the ground begins to inflate again. Slowly, steadily, at a rate of roughly a couple of microradians a day. And the scientists have learned that when the inflation climbs back up to a certain threshold, somewhere in the range of 8 to 10 microradians of net refilling, the reservoir is full enough and pressurized enough to erupt again. So they're not guessing, they're watching a tank refill at a known rate toward a known trigger point and doing arithmetic. As of the latest reading before this video, the summit had already recovered around 12 microradians of tilt since the last episode emptied it. Do the math, and you understand why they could circle a day on the calendar. The tank is nearly full. I have to give you one honest asterisk, the kind this channel always gives you. Some of the summit monitoring stations have been knocked offline recently by storms and power outages, which means the team is working with a slightly thinner stream of data than usual. The forecast is a forecast, not a guarantee. Volcanoes have surprised the experts before, and a few of these very episodes arrived a day early or a day late. But the rhythm has held remarkably well, episode after episode, which is exactly why we can have this conversation at all. The volcano is, for now, behaving like a volcano on a clock. And that clock, that predictable in and out breathing of the mountain, isn't just a forecasting trick. It's telling you something profound about what's actually happening under the ground. So let's go down there. To understand why this volcano is so predictable, you have to throw out the cartoon image of a volcano. Forget the cone-shaped mountain that explodes once in a great catastrophe and goes quiet for 1,000 years. Kilauea is a completely different kind of beast, and the way it works is the key to this entire story. Picture, a few miles beneath the summit, a reservoir of molten rock, not a giant cartoon cavern of glowing liquid, but a zone of hot, partly molten rock, pressurized, connected by a plumbing system to the deep source far below that feeds the whole Hawaiian island chain. That deep source is what geologists call a hotspot, a persistent plume of heat rising from deep in the planet, and the big island sits right on top of it. The magma is always coming. The supply, in a sense, never really stops. It just paces itself. Now here's the breathing. Magma rises from the deep source and fills that shallow reservoir under the summit. As it fills, the pressure builds, and the ground above swells. That's the inflation the tiltmeters measure. The mountain is breathing in. The pressure climbs and climbs until it overwhelms whatever is holding it back, and then the magma forces its way up to the surface through the vents in the crater, and it erupts. As it pours out, the reservoir drains, the pressure drops, the ground sinks back down. The mountain is breathing out, and then the eruption sputters and stops, not because the volcano is done, but because it has temporarily relieved the pressure, and then the deep supply, which never stopped, begins refilling the reservoir again, and the whole cycle starts over. Inflate, erupt, deflate, pause, refill, inflate, erupt. That is the rhythm. That is the breathing. And once you see it as breathing, the predictability stops being mysterious. The scientists aren't forecasting a random catastrophe. They're timing a breath. They're watching the chest rise, measuring how fast, and calculating when the next exhale comes. Let me give you the analogy I keep coming back to. Imagine an old-fashioned percolator coffee pot, or a fountain that surges on a timer. Pressure builds in a chamber, releases in a burst, then builds again. Or think of a geyser, like Old Faithful, which erupts on a schedule because it heats and pressurizes water in a consistent cycle. Kilauea, right now, is doing the volcanic version of that. It has found a stable, repeating cycle, and a repeating cycle is a predictable one. This is why the experts make a careful distinction that matters for the rest of this video. They don't call these 50 separate eruptions. They call them 50 episodes within one ongoing eruption. The eruption is the whole continuous process that started in December 2024. The episodes are the individual breaths, the bursts of fountaining, separated by the pauses. It sounds like a technicality, but it's the heart of it. This is not 50 disasters. It's one long, living, breathing event, and we are watching it inhale right now. But here's the thing about that breathing, the turn that sets up everything dark in this story. Every single time the mountain exhales, it doesn't just release lava, it releases gas. Enormous quantities of it. The same pressure cycle that makes the eruption so beautifully predictable is also a machine for pumping poison into the air, on a schedule. Hold that thought. We're coming back to it, and it's the part that actually hurts people. For now, let's go up to the surface and watch what that exhale actually looks like, because it is one of the most spectacular things this planet does. When Kilauea breathes out, it does not trickle, it roars. Let me describe what the last episode, episode 49, actually looked like, because the numbers are almost hard to believe, and every one of them is straight from the observatory's own report. It began on the morning of June 14th. After about 5 hours of warning signs, the instruments picked up first, and then the north vent in the summit crater opened up and started to fountain. Not a flow, not an ooze, a fountain. A continuous jet of molten rock blasted straight up into the sky, and it climbed. Within about an hour, it had reached its peak height of nearly 700 feet. 700 feet of liquid fire, sustained, standing in the air like a building made of lava. Let that scale land. 700 feet is taller than a 60-story skyscraper. Imagine a jet of molten rock, glowing orange and yellow and white-hot at its core, roaring up to the height of a major office tower and holding there hour after hour. That episode lasted about 7.5 hours of continuous fountaining, and when it was over, fresh lava covered something like 40 to 50% of the crater floor. Half the floor of the crater resurfaced in a single afternoon. And by the standards of this eruption, episode 49 was not even the most extreme. Earlier episodes have thrown fountains that topped 1,000 feet, fountains so tall they were visible from the town of Hilo, 30 miles away. People stood in a city 30 miles from the vent and watched a column of fire rise over the horizon. Another episode sent a plume of gas and ash climbing to 20,000 feet into the atmosphere, into the altitude where airliners fly, which is exactly why there's an aviation color code in the first place. So why does a volcano fountain like that, instead of just flowing? The answer is gas, and it's the same answer that's going to matter enormously later. The magma deep down has gas dissolved in it, mostly water vapor, carbon dioxide and sulfur dioxide, held in solution by the immense pressure, exactly the way carbon dioxide is dissolved in a sealed bottle of soda. As the magma races up toward the surface, the pressure drops, and that dissolved gas comes screaming out of solution into bubbles, expanding violently. It's the soda bottle you shook before opening. The gas expands so fast and so forcefully that it doesn't just push the lava out, it sprays it, blasting molten rock skyward in that towering fountain. The fountain is, in a very real sense, the volcano violently exhaling its gas and dragging the lava along for the ride, which means the fountain you see and the gas you don't are not two separate things. They are the same event. The spectacular fire and the invisible poison come out of the ground together, driven by the same expanding gas. The camera loves the fountain, the lungs feel the gas, and almost all the coverage you'll see points the camera at the fountain. Now, here's a crucial detail that the scary headlines tend to leave out, and it's genuinely reassuring. All of this, all 50 episodes, all that fire, has stayed inside the summit crater, inside a closed area of a national park. The observatory reported that the tephra, the bits of volcanic debris from the last episode, fell almost entirely within the closed zone. No significant debris in the visitor areas. None reported in the surrounding communities. The lava is not flowing toward anyone's house. It is not threatening a town. As a pure lava hazard, this eruption has been, so far, contained and relatively benign. So if the lava isn't the threat to people, you might reasonably ask what is. And that's where this story turns, and where it stops being a fireworks show and starts being a public health story that stretches 100 miles downwind. But before we get there, we need to understand the record this eruption just shattered, because it tells you something important about how unusual this whole event really is. To understand why 50 episodes is a genuinely historic number, and not just a big round figure, we have to go back to the early 1980s, to the eruption that every Hawaii volcano scientist measures the present against. It was called Puʻu, and for decades it was the benchmark for this exact kind of fountaining behavior at Kilauea. Starting in 1983, Kilauea entered a long eruption along its east rift zone, the line of weakness running down the volcano's flank. And in the early phase of that eruption, between 1983 and 1986, it did something similar to what it's doing now. It produced a series of high lava fountains, episode after episode, from a vent that built itself into a towering cone of cooled spatter. That early fountaining phase produced 47 episodes. 47. For almost 40 years, that number stood as the record for episodic high fountaining at Kilauea. It was the most anyone had ever documented. The eruption we're watching right now passed it. Earlier this year, when this current eruption hit its 48th episode, it quietly broke a record that had held since the Reagan administration. It became the most episodic high fountaining eruption ever recorded at this volcano. And it didn't stop there. It kept going. 49. And now, any day now, 50. The volcano isn't just performing, it's rewriting its own record book, episode by episode. And nobody, not even the scientists watching it most closely, can tell you where the cycle finally ends. Now, I want to be careful and precise here, because this is exactly the kind of fact that gets twisted online. When you hear, broke a 40-year record, the conspiracy instinct is to hear, unprecedented, unnatural, something is wrong with the Earth. So let me be clear about what the record actually means. It means this particular style of eruption, the repetitive high fountaining from the summit, has gone on for more individual episodes than we've documented before. It does not mean the volcano is more dangerous than it's ever been. It does not mean something unnatural is happening. Kilauea is one of the most active volcanoes on the planet. Erupting is what it does. It has been erupting, on and off, for as long as humans have lived on these islands, and far longer. What's genuinely remarkable is not that it's erupting, but the rhythm, this metronomic, breathe in, breathe out, episode pause episode pattern is unusual, and it's a scientific gift. Each episode is a natural experiment. The observatory gets to watch the same process repeat again and again, refining their understanding of how magma fills a reservoir, how pressure builds, how a fountain is born. 50 times over. There may be no better natural laboratory for understanding this kind of volcanism anywhere in the world right now. The record isn't a warning sign. It's a research bonanza. And it tells you one more thing. This volcano is not winding down. A volcano that has produced 50 fountaining episodes in under 2 years and is still inflating on schedule for the next one is a volcano in the middle of a sustained, vigorous, ongoing eruption, which means the hazard we're about to talk about, the one that actually reaches people, isn't a one-time event. It's a recurring exposure, delivered on that same reliable schedule, episode after episode after episode. And to understand why that matters, we have to talk about where this is happening and who lives downwind. It's easy, watching footage of a lava fountain in Hawaii, to file this under exotic, faraway nature, something happening on a distant tropical island that has nothing to do with daily life in the continental United States. But that instinct is wrong, and correcting it is important, because this is unfolding on American soil, in one of the crown jewels of the American public lands system. Kilauea sits inside Hawaii Volcanoes National Park, on the Big Island of Hawaii. This is a United States national park, managed by the National Park Service. the same agency that runs Yellowstone and the Grand Canyon. The summit crater where all this fountaining is happening, Halemaʻumaʻu, is one of the most visited and most sacred sites in the park. In Hawaiian tradition, it is understood as the home of Pele, the deity of volcanoes and fire. This is not abstract foreign geology. It's a place where Americans go on vacation, where they hike, where they stand at overlooks and, in the right conditions, watch one of the most powerful natural displays on the planet. And that brings us to the human geography. The closest community to the summit is a small place called Volcano Village, sitting just a few miles from the active crater. A few miles. The people who live there are, more or less, the volcano's next-door neighbors. About 30 miles to the northeast is Hilo, the largest town on this side of the island, home to tens of thousands of people, and the place from which residents have, during the bigger episodes, been able to watch fountains rise over the landscape from their own neighborhoods. Now here's a tension that makes this story so interesting and so American. For most disasters, the event is purely a threat. A hurricane is bad news, full stop. But this eruption, contained as it has been inside the park, is also an extraordinary economic engine. When the lava fountains, people come. Flights fill up, hotels book out, helicopter tours sell out. The park, when it's safely open, draws crowds who have crossed an entire ocean for the chance to witness Pele at work. The eruption is, in a strange way, both a hazard and one of the Big Island's greatest attractions at the very same time. That dual nature is exactly why the management of this eruption is so delicate, and why the National Park Service plays such a careful game. During an active, vigorous fountain episode, the park may temporarily close the most exposed areas because of the debris and the gas. And then, often within hours of an episode ending, those areas reopen. It's a constant, real-time balancing act between public safety and public access, between protecting people and letting them witness something genuinely awe-inspiring. The rangers at the entrance station are, in a real sense, the front line, making judgment calls based on the same observatory data we've been talking about. So when you watch this eruption, don't watch it as a foreign spectacle. Watch it as an American landscape, with American communities a few miles downwind, in an American national park, managed by American scientists and rangers who are making live decisions about the safety of American citizens and the millions of visitors who come to see it. And the central decision they're making, day in and day out, has almost nothing to do with the lava you can see. It's about the thing you can't, which is where we go next. Here is the heart of this whole story, the part that almost every viral clip leaves out. The most dangerous product of this eruption is not the lava, it's a gas, and it has a name that sounds almost gentle, almost like weather: Vogue. VOG is short for volcanic smog, and to understand it, we have to go back to that gas we talked about, the gas that drives the fountains. When Kilauea erupts, and even when it's just sitting there degassing between episodes, it releases enormous quantities of sulfur dioxide. Sulfur dioxide is a sharp, acrid gas, and during the quiet pauses between episodes, the summit has been pumping it out at a rate in the range of 1,000 to 5,000 tons per day. And during the actual fountain, when the volcano is violently exhaling, that rate spikes far, far higher. Now here's the chemistry that turns a gas into a public health hazard across an entire region. That sulfur dioxide doesn't just stay put, it drifts downwind, and as it travels through the air, in the sunlight and the moisture, it reacts. It combines with oxygen, water vapor, and other particles in the atmosphere, and transforms into a fine haze of sulfate aerosols and tiny acidic droplets. That haze is VOG. It's a chemical fog, born from the volcano's breath, and it can hang over communities tens of miles away, far from any lava, far from any visible danger. And VOG is not just unpleasant to look at, it's a genuine respiratory hazard. Those fine particles and acidic droplets are small enough to be drawn deep into the lungs. For healthy people, heavy VOG can cause headaches, sore throats, watering eyes, coughing, fatigue. But for the people who are vulnerable, and there are millions of them in any population, it's far more serious. For someone with asthma, VOG can trigger an attack. For someone with chronic lung disease or heart disease, it can mean a genuine medical crisis. Children, the elderly, pregnant women, anyone with a respiratory condition, these are the people for whom an invisible gas drifting off a volcano becomes a trip to the emergency room. This is the cruel inversion at the center of the story. The lava, the thing that looks terrifying, the 700-foot fountain of fire, has stayed safely inside a closed national park and hasn't directly harmed a single home. But the gas, the thing you often can't even see, travels for miles, settles over towns, and quietly sends vulnerable people to the hospital. The danger ran in exactly the opposite direction from where everyone is pointing their cameras. The spectacle is contained, the actual hazard is mobile. And remember the breathing cycle, the predictability we admired earlier. Here's the dark side of that same coin, the one I told you to hold on to. Because this eruption is episodic and ongoing, the VOG isn't a one-time cloud that passes and is gone. It's a recurring exposure. Every episode is another pulse of sulfur dioxide. Every pause is more steady degassing. The people downwind aren't dealing with a single bad day. They're dealing with an on-again, off-again exposure that has continued, episode after episode, for well over a year, and that will keep coming as long as the volcano keeps breathing on its schedule. The very thing that makes this eruption so predictable, the relentless rhythm, is the same thing that makes the VOG a chronic, repeating burden on the communities in its path. So which communities are in the path? That depends entirely on something the volcano doesn't control at all: the wind. And the geography of where this poison goes is its own remarkable story. Where the VOG goes is decided by the trade winds, the steady winds that blow across Hawaii from the northeast for most of the year. And under normal trade wind conditions, the volcanic gas from Kilauea gets pushed toward the southwest. It rolls down off the summit and flows toward the southern and western parts of the Big Island. That's why some of the most affected communities aren't the ones closest to the crater. They're the ones downwind. Towns on the south and west sides of the island can sit under the VOG repeatedly, even though they're nowhere near the lava. A place can be miles and miles from any glowing rock and still have the worst air quality on the island simply because it sits where the wind delivers the gas. Some downwind communities have, during the more intense phases of Kilauea's activity over the years, seen their air quality pushed into ranges that public health agencies flag as unhealthy, especially for those sensitive groups we just talked about. And then there's the famous Kona coast, on the western side of the island. Under those normal trade winds, the gas drifts down the coast, and in the afternoons the local sea breezes can push it back inland and let it pool. The result is that the beautiful sunny Kona side, the postcard side of the Big Island, can develop a persistent hazy quality during active volcanic periods. That haze, softening the horizon, dimming the sun, is the volcano's breath, carried dozens of miles and settled over a coastline full of homes, resorts, and people. But here's where it gets even more far-reaching, and where it stops being only a Big Island problem. The trade winds don't always blow. Sometimes the weather pattern reverses, in what locals call Kona winds, when the wind comes from the south or southwest instead. And when that happens, the VOG gets carried in the other direction, northward, up the island chain. During past periods of strong emissions from Kilauea, VOG has been carried beyond the Big Island entirely, reaching Maui, and in some conditions the plume has been documented drifting all the way up to the most populated island of all, Oahu, home to Honolulu and the majority of Hawaii's population. A volcano on one island, fouling the air over a city on another island, a couple hundred miles away. That's the reach of an invisible plume that no camera bothers to film. I want to be fair and precise here, the way this channel tries to be. How bad the VOG gets on any given day depends on a lot of variables. How vigorously the volcano is degassing, which direction, and how strongly the wind is blowing, whether it's an active fountaining episode or a quieter pause. There are days when the air downwind is just fine. The point is not that all of Hawaii is choking all the time. It isn't. The point is that the hazard from this eruption is not measured in the few square miles of crater where the lava is. It's measured across the whole downwind region, on a map drawn not by geology but by the wind, and it can stretch from a village a few miles away to a city on the far side of the island chain. And that gap, between where the danger looks like it is and where it actually goes, is the whole reason this channel exists. because the people living in that gap are real. They aren't a statistic on a hazard map. So let's talk about them, honestly, without inventing a single one. I want to slow down and talk about the people, because it would be easy to keep this whole thing in the language of microradians and tons of sulfur dioxide and stay comfortably distant from it. But there are human beings living under that invisible plume, and I'm going to tell you about them honestly, which means I'm not going to invent anyone. No fictional asthmatic grandmother, no scripted quote from a worried mother, just what we actually know about who lives in the path. Start with Volcano Village, the community sitting just a few miles from the active crater. Think about what it means to live there right now. Your neighbor is a volcano that is, by the observatory's own forecast, about to erupt for the 50th time. You've learned to read the same signs the scientists read: the glow on the horizon at night, the shift in the air, the smell of sulfur when the wind turns wrong. For the people in Volcano Village, the eruption isn't a video on a screen, it's the weather. It's the thing that determines whether you keep the windows open tonight, whether the kids play outside, whether the air coming through the screen door is clean or carries that acrid edge. Then move downwind, to the south and west, to the communities that sit where the trade winds deliver the gas. These aren't people who chose to live next to a lava fountain. Many of them live miles and miles from any visible volcanic activity. They live in ordinary towns, working ordinary jobs, and the volcano reaches them anyway, through the air, on the days the wind decides to carry it their way. For someone in one of those downwind towns with a child who has asthma, the volcano's breathing schedule and the daily wind forecast become something you actually have to plan your life around. Not dramatic, just relentless. The low, grinding kind of burden that doesn't make the news because it doesn't photograph. And then there are the people whose livelihoods are tangled up in all of it. The park rangers making real-time calls about when to close an overlook and when to reopen it. The scientists at the observatory, working with some of their instruments knocked offline by storms, still managing to forecast the next episode to within a few days. The tour operators, the helicopter pilots, the hotel workers, the whole economy that rises and falls with the volcano's moods. For them, this eruption is simultaneously their paycheck and their occupational hazard, the thing that brings the tourists and the thing that fouls the air they breathe at work. This is what I mean when I say the truth doesn't need exaggeration. I don't need to write you a tearful character to make this matter. The real situation is enough. A small town a few miles from a crater that's about to erupt again. Downwind communities where the air quality is set by a volcano and a wind map. Vulnerable people, the children and the elderly and those with weak lungs who carry the heaviest share of an exposure they never signed up for. And a community that has learned, out of necessity, to live in rhythm with a breathing mountain. The honest version is heavier and more human than any character I could invent. And there's a deeper truth running underneath it, the same one that runs under every story this channel tells. The people most affected by a natural hazard are rarely the ones generating the spectacle or the headlines. They're the ones quietly absorbing the cost, downwind, out of frame. The cameras are pointed at the 700-foot fountain. The actual weight of this eruption is being carried, a breath at a time, by people you'll never see in the footage. Now, I've been telling you that this eruption has been relatively gentle, contained in the park, dangerous mainly through its gas. And that's true right now. But Kilauea has another face, a face it showed just a few years ago, and that one was not gentle at all. To understand the full range of what this volcano can do, we have to talk about 2018. Everything I've described so far, the contained summit fountains, the lava that stays inside the national park, the hazard that's mostly about gas, that's Kilauea in one mood. But this same volcano, fed by this same plumbing, is capable of something dramatically different. And the last time it showed that other face was in 2018, and it was a genuine disaster. In 2018, the action wasn't at the summit. It was way down the East Rift Zone, that line of weakness running down the volcano's flank, through inhabited areas, including a residential subdivision called Leilani Estates. And instead of a tidy fountain in a closed crater, the ground in people's neighborhoods began to crack open. Fissures, splits in the earth, tore through the area, and lava began erupting directly into a community where people lived. More than 20 separate fissures opened up over the course of the eruption. The numbers from 2018 tell a completely different story from the one we've been telling tonight. That eruption produced tens of thousands of earthquakes as the ground deformed and shifted, a relentless seismic drumbeat that went on for weeks. The lava didn't stay politely in a crater. It flowed through neighborhoods, across roads, over farmland, all the way to the ocean, and it destroyed homes. The most cited tallies put the number of structures destroyed in the area of around 700 buildings. Around 2,000 people had to be evacuated from their homes, many of whom would never get those homes back. The lava overran a geothermal power plant that supplied a significant share of the island's electricity. Whole neighborhoods were simply erased, paved over in black rock that's still there today. And at the same time, up at the summit, something equally dramatic was happening. As all that magma drained out of the system and erupted down in the rift zone, the floor of the summit caldera lost its support and began to collapse. It didn't fall all at once. It came down in a series of collapse events, dozens of them, each one releasing energy comparable to a moderate earthquake, each one dropping the crater floor further. By the time it was over, the summit of Kilauea had been radically reshaped, the crater dramatically deeper and wider than before. The volcano had, in a matter of months, rebuilt its own summit. I'm telling you this not to frighten you about the current eruption, but to give you the full, honest picture of the machine we're dealing with. Because here's the crucial point. The 2018 catastrophe and the gentle summit fountains of today are produced by the same volcano, fed by the same deep magma supply, governed by the same plumbing. The difference between them isn't a different volcano, it's a different pathway. In 2018, the magma found its way to the surface down in the populated rift zone. Today, it's coming up quietly at the summit, inside the park. Same source, same fundamental forces, wildly different consequences depending entirely on where the magma decides to come out. Which raises the obvious, uncomfortable question, the one the scientists are quietly watching for every single day. If this volcano did that in 2018, could the current eruption change its character? Could the magma shift from the safe summit back down toward where people live? That's the real question worth asking, not the fantasy about collapsing islands and giant waves, but this grounded, legitimate one. So let's answer it honestly. Could this eruption change its character? Could the activity migrate from the contained summit down into the rift zones where people live, the way it did in 2018? This is the question that actually deserves your attention, and I want to answer it with the same honesty I'd want if it were my family living in Volcano Village. The honest answer is in two parts. First part. Yes, in principle, a volcano like Kilauea can change its behavior. We just saw that it has two very different modes, summit and rift zone, and the magma's pathway can shift over time. No serious scientist would tell you it's physically impossible for this eruption to evolve. Volcanoes are not bound by contracts. That's exactly why the observatory monitors the rift zones continuously, and not just the summit. But here's the second part, and it's the part that should bring your blood pressure back down. As of right now, the data shows no sign of that happening. In their updates, the observatory has been explicit that no significant activity has been detected along the East Rift Zone or the Southwest Rift Zone. The action is all at the summit. The magma is going up into Halemaʻumaʻu, fountaining, draining back and refilling in that tidy, predictable, contained rhythm. There is no current indication that it's heading for the neighborhoods. The thing that made 2018 a disaster, magma intruding into the populated rift zone, is not what the instruments are showing today. And this is the beautiful, reassuring flip side of all that monitoring we talked about. Remember those tiltmeters, the seismometers, the gas sensors, the whole web of instruments wired across this volcano? Their job isn't only to forecast the next pretty fountain. Their deeper job is to catch exactly this kind of change. If magma started moving down into a rift zone, it would announce itself. The earthquakes would migrate, following the magma's path underground. The ground deformation would shift, swelling in a new place. The patterns would break from the summit rhythm. The observatory has seen this signature before, in 2018 and in other events, and they know what it looks like. They are, quite literally, watching for it around the clock. The very surveillance that lets them forecast the next episode is the same surveillance that would give warning if the volcano tried to do something far more dangerous. So the grounded, real answer is this. The current eruption is, for now, in its contained summit mode, with no sign of shifting toward populated areas, and an extensive monitoring network stands ready to detect it if that ever changes. The danger from this eruption, today, is the VOG, not a repeat of 2018. That could change on a longer timescale, and the scientists know it, which is why they never stop watching. But there's a world of difference between a monitored possibility the experts are tracking and an imminent catastrophe. The first is just honest science. The second is a story someone tells you to make you afraid. And speaking of stories told to make you afraid, it's time to deal with the big one. Because while the real scientists are calmly watching rift zone seismicity, a very different version of Kilauea is going viral. One involving a collapsing mountainside and a wall of water tall enough to swallow a coastline. So let's take it seriously, and then let's take it apart. So let's talk about the version of this story that's racing across social media right now. It goes something like this. Kilauea, or sometimes its giant neighbor, is unstable. One side of the volcano is going to catastrophically collapse, a huge chunk of the island sliding into the Pacific all at once. And that collapse will generate a mega tsunami, a wave hundreds of feet tall, that races across the ocean and obliterates the west coast of the United States. Maybe the east coast too, depending on which version you're watching. It's dramatic, it's cinematic, and it's almost entirely wrong. I want to take this one seriously, because dismantling it carefully teaches you real science. And because, like most effective fear, it's built on a tiny kernel of something real, wrapped in a mountain of exaggeration. Here's where it comes from. There's a genuine scientific hypothesis, decades old now, about a volcano on the other side of the planet, Cumbre Vieja, in the Canary Islands. Back around the year 2000, a pair of researchers published a model suggesting that a future eruption could cause a massive flank of that volcano to collapse into the Atlantic in one piece, generating a wave that could cross the ocean and strike the Americas. It got enormous media attention. It became the template for every island collapse mega tsunami story since. And the Kilauea version you're seeing now is essentially that same idea, copied and pasted onto a Hawaiian volcano. The problem is, that original hypothesis was heavily challenged by other scientists almost immediately, and the criticism has only grown. Here's the core of it. The doomsday scenario depends on the entire flank failing as a single, coherent block, all at once, like a giant slab sliding off a table. That's what would be needed to shove enough water to make an ocean-crossing megawave. But that's not how these collapses actually tend to happen. The geological evidence from past flank collapses around the world suggests they usually happen in stages, in pieces, as a series of smaller failures spread over time, not one catastrophic all-at-once slab. And a collapse that comes apart in pieces, over time, produces far smaller, more local waves, not a coherent ocean-spanning monster. The energy gets fragmented instead of focused. Now let's bring it specifically to Kilauea, because the United States Geological Survey has addressed this directly, and their position is about as clear as government scientists ever get. There is no geological evidence for the kind of past catastrophic collapse of Kilauea that would be needed to generate a major Pacific tsunami, and such an event is considered extremely unlikely based on the actual monitoring of the volcano. Read that carefully. They're not saying the volcano does nothing. They're saying the specific doomsday scenario, the coherent flank collapse that launches a continent-killing wave, is not supported by the evidence and is extremely unlikely. Here's the kernel of truth the fear is built on. Kilauea's south flank really does move. It creeps slowly seaward, driven by the pressure of magma in the system, and that slow movement is real and monitored. In fact, back in 2018, there was a magnitude 6.9 earthquake on that flank, related to that movement. So the flank is not perfectly stationary. But, and this is everything, slow creep and the occasional related earthquake is a completely different thing from a sudden, catastrophic, coherent collapse of the entire mountainside. One is a monitored, gradual process measured in inches. The other is a Hollywood scenario that the geology doesn't support. The fear takes the real thing, the slow creep, and inflates it into the fake thing, the instant island-shattering collapse. That's the trick. A real seed, grown into an impossible tree. So no, the wave isn't coming. Not from this eruption, not in any time frame you need to worry about. The people who should be thinking about Kilauea's hazards are the ones downwind of the VOG, not the ones on a beach in California watching the horizon. And anyone selling you that wave is selling you fear, not science. The mega tsunami is the biggest myth attached to this eruption, but it travels with a little entourage of smaller ones, and I want to knock them down quickly, because you're going to encounter all of them in the comment sections and the algorithm's darker corners. First, the old favorite, HAARP. Anytime anything happens on or in the Earth these days, someone claims it was triggered by HAARP, the research facility in Alaska that studies the upper atmosphere. We covered this in detail in another video, so here's the short version. HAARP beams radio energy up, into the ionosphere, around 60 miles above the ground. A volcano is fed by magma rising from miles below the ground. The energy is pointed the wrong way, at the wrong target, and it's millions of times too weak to do anything to a magma system anyway. But more to the point, in this specific case, we don't need to invoke anything mysterious at all, because we can watch the actual cause. We can see the tiltmeters record the magma filling the reservoir. We can see the ground inflate. We can see the gas. The cause is measured, in real time, by instruments. There's no gap for a secret weapon to hide in. The volcano is explaining itself, out loud, in data. Second myth, the idea that volcanoes are waking up all over the world, that we're in some unprecedented surge of global volcanic activity that signals the planet is destabilizing. This one feels true because of the algorithm, not because of the Earth. Here's the reality. From the Smithsonian's Global Volcanism Program, which tracks this globally, on any given day there are roughly 20 volcanoes erupting somewhere on Earth. Every day. That's normal. That's the baseline. Over the past couple of decades, the average number of volcanoes that erupt in a given year has held steady at around 70 or 80. It is not climbing. What's changed is not the number of volcanoes, it's the number of cameras, the number of social accounts, and the appetite of a recommendation algorithm that has learned you'll click on the word erupting. You're not seeing more volcanoes, you're seeing more videos. The Earth is exactly as volcanically active as it has always been. You just have a front row seat now. Third, and this one comes up every single time any American volcano makes the news, Yellowstone. The moment Kilauea trends, somebody connects it to the Yellowstone supervolcano, as if all the volcanoes are wired together and one going off means the big one is next. They're not connected. Kilauea, in Hawaii, sits over a hotspot in the middle of the Pacific Plate. Yellowstone sits over a completely separate hotspot under the North American continent, thousands of miles away. They have nothing to do with each other. And as for Yellowstone itself, its monitoring status is, as it has been for years, completely normal. Normal alert level, normal background activity. The United States Geological Survey watches it more closely than almost any volcano on Earth, and they will tell you plainly, there is no indication of an impending eruption. Kilauea fountaining in Hawaii tells you precisely nothing about Yellowstone, because the two share nothing but the word volcano. Do you see the pattern across all of these? Every single myth takes your attention and points it somewhere useless. At a facility in Alaska, at a fake global surge, at a supervolcano half a continent away, at a wave that isn't coming, and every one of them points you away from the one real, boring, actually useful hazard, the gas, drifting downwind, reaching the people who actually have to live with this volcano. The fear is always loudest exactly where the real danger isn't. So here we are, a volcano about to erupt for the 50th time in a single ongoing eruption, on a schedule we can read, in a national park full of visitors, beside communities that have learned to breathe in rhythm with it. Let's go back to the question I asked you to hold on to at the very beginning. How can scientists predict this volcano almost to the day, when they can't do it for nearly any other? Now you know the answer. It's because this eruption found a rhythm. The breathing, inflate, erupt, deflate, refill, inflate again. A repeating cycle is a readable cycle, and the instruments buried in this mountain can read it like a heartbeat on a monitor. That's the gift of Kilauea right now. It's one of the most legible volcanoes on the planet. But remember the second half of that question, the part I promised would matter. Why does the very thing that makes it predictable also reveal where the real danger is? because the rhythm, the relentless episode after episode breathing, is also the engine of the gas. Every breath out is another pulse of sulfur dioxide, another wave of vogue rolling downwind. The predictability and the hazard are the same phenomenon, seen from two angles. The clock that lets the scientists forecast the next fountain is the same clock that schedules the next exposure for the people downwind. Two sides of one coin, exactly as I promised at the start. And here's the takeaway I want to leave you with, the practical one. When you see the footage of this eruption, the 700-foot fountains, the rivers of fire, let yourself be awed. It is one of the most magnificent things our planet does, and it's happening on American soil, predicted by American scientists, in real time. That's genuinely something to marvel at. But don't mistake the spectacle for the hazard. The fountain is the show, the gas is the threat, and the people who need your attention are not on a distant beach waiting for an impossible wave. They're a few miles downwind, watching the air, planning their day around a volcano's breathing and a wind forecast. The real story was never the lava, it was never the wave. It was the thing you couldn't see, carried on the wind, to people just trying to live next to a mountain that won't stop exhaling. 50 episodes. And as of tonight, no one, not the scientists, not anyone, can tell you whether this eruption stops at 50 or 55 or keeps breathing for another year. The mountain will decide on its own schedule, and the instruments will keep reading it, breath by breath. If this changed how you see that volcano, then there's one more thing you need to understand, because it's the question this whole eruption is quietly forcing. We just spent this entire video on a volcano we can predict, but most of the volcanoes capable of killing the most people are the ones we can't read at all, the quiet ones, the ones that sit silent for centuries and give almost no warning before they go. There's one in particular, sitting near a major population center right now, that has scientists far more worried than anything happening in Hawaii, and almost no one is watching it. That's the story we're telling next, and you're going to want to see it before it makes the headlines. It's on the screen now. We'll see you there.